What is up, young chemist? Mr. Rosen here. How's it going? Today we're going to be looking at pressure and volume and their relationship with the properties of a gas. So we have kind of quite the setup here. This is what's called a bell jar. Okay, I'm going to pick this up. It's a thick-walled glass jar, and it's sitting on a base. And there's a little valve on the bottom of the base. There's a tube running out the bottom of the base, and it eventually goes into this right here, which is a vacuum pump. Okay, now when I turn the vacuum pump on, it's going to make some noise. And when I open the valve here at the bottom of the base plate, the vacuum pump will pull gas out of inside of the bell jar. Okay, so right now we're in a room, or I'm in a room full of gas. Gas particles are bouncing off of me on all sides. And the same is true for this balloon right here. This balloon is sealed, and it has there's gas inside, and the gas inside has some volume at our current temperature in this room and at our current pressure in this room. So what you should think about is inside this balloon, you think, why does it have the shape that it has or the size that it has? Inside the balloon, there are gas particles bouncing off of the inside walls. And when a gas particle hits the inside wall and bounces off, it exerts a force. Okay, we call that the pressure on the inside pushing out. And at the same time, there are gas particles here in the room hitting the outside of the balloon and bouncing off of them. Now, at our given temperature, there's a balance between the gas particles inside pushing out and the particles of gas on the outside pushing in. And so it has this volume. Now, I'm going to place this sealed balloon here on the base plate, and then I'm going to put the bell jar on top. And I'm going to turn the vacuum pump on. When the vacuum pump turns on, it's going to take air, gas, from inside of the bell jar and remove it. Okay, so it's actually going to be lowering the pressure acting on the outside of the balloon. So right now I have the experience of 1 atmosphere of pressure. If there were half as many gas particles around me, I would experience the pressure of half of an atmosphere. Effectively, we are we're creating a low pressure zone inside of the bell jar. It'd be like lowering the atmospheric pressure, lowering the pressure acting on the balloon. And let's see what happens. But before I turn it on, make a prediction. What do you think is going to happen to this balloon when I turn the vacuum pump on? Make a prediction, please. Okay, I'm going to turn the vacuum pump on, and then I'm going to open the valve. Let's see if you notice any changes in the balloon. Vacuum pump's on. Opening the valve. Pressure is lowering, pressure is lowering, pressure is lowering. What's happening to the volume of the balloon? Pressure is lowering, pressure is going down, pressure is going down. Now it's on the sides. Okay, now remember, the balloon is sealed. The same amount of gas is inside the balloon right now as it was before. But look at the difference in the volume that gas takes up. So as I said, inside the balloon, there are gas particles hitting the inside of the balloon and bouncing off. But outside of the balloon, there were gas particles hitting the outside, and a balance was reached. Now, inside the bell jar, the vacuum pump has removed a bunch of gas from the space around the balloon. So now the gas particles inside pushing out are the same as before, but there are not as many gas particles on the outside pushing in on the balloon. And so as the pressure inside the bell jar lowered, the volume of the gas increased, okay? Pressure goes down, volume goes up. Inverse relationship. This is Boyle's law in action. Now watch what's going to happen. I'm going to open the valve here and let some gas back in. Here we go. So just like heat flow, heat will always flow from higher temperatures to lower temperatures. With pressure, air or a gas will always move from high pressure regions into low pressure regions. So right now it's low pressure inside of the jar compared to outside. So when I open the valve, we might hear a hissing noise. Air from the room is going to move into the bell jar. And as the air moves into the bell jar, the pressure inside is going to increase, increase, increase. And watch what happens to the volume of the balloon as the atmospheric pressure here increases. Here we go, opening the valve. Gas is coming back in, gas is coming back in. There's more and more gas particles around the balloon pushing in on it. Volume is decreasing, volume is decreasing, volume is decreasing. And then gas will continue to move from high pressure to low pressure until there is no difference in pressure. At that point, no gas will flow between them. Okay, no air is flowing between them, and now I can just simply lift this up. And we're back to how we started. Same volume, still sealed, same temperature, but you saw how the volume changed as we lowered the pressure acting on the balloon. The next thing we're going to do is look at some shaving cream, okay? I'm gonna put some shaving cream into this evaporating dish. Here we go. Now, even this container, right, this metal container, if you notice, when you look at this container, a hard metal container like this with a little button, you push the button and stuff comes out, that's using gas laws. We have a rigid container and gas has been forced into this container. So inside of this container is high pressure and outside is low pressure. So when I open the valve by pushing this button, gas moves from high pressure out to low pressure and carries with it this solution, you know, of oils and fragrance and everything else. Now, the same thing happens with a spray paint can, an aerosol can, you know, you want an air freshener or something like that. They have gas at high pressure, and when you open the valve, it moves to low pressure and carries with it whatever you are, whatever the product is, whether it's paint or a fragrance or shaving cream. You also might notice that on the side it says, warning, contents under pressure. And then it says, do not heat or incinerate. Why is that? Well, if you have a gas and it's in a container and it's already under high pressure, what would happen if you then heat the gas? Charles' law, temperature goes up, volume goes up. But if it's already under high pressure and the volume can't change, as temperature goes up, the pressure builds up, particles are hitting the inside harder and harder, faster and faster, until possibly the integrity of the container is broken, right? The container will burst and you could have an explosion. So, gas laws. Now, let's see what happens to the shaving cream. You can see the size of it. It's probably about the size of a golf ball. See what happens to the shaving cream as we lower the pressure acting on it. We're effectively creating a low atmospheric pressure environment. Here we go. Bell jar is turning on, or vacuum pump's turning on. Opening the valve. The pressure is lowering. Gas is getting sucked out. Gas is getting sucked out. Pressure is lowering. Look at the change in the volume of the shaving cream. It's actually touching the wall now. Alright, I'm going to stop there, but you can obviously see the volume of the shaving cream now compared to where we started. And it's actually touching the wall of the glass, so that will break up the bubbles and it might get a little bit smaller here. But again, as the pressure lowers, the volume increases. And shaving cream, the reason it's so light and frothy and fluffy like that is because it's mostly gas. A whole bunch of little gas bubbles are in the shaving cream. And each little gas bubble increases its volume, and you can see overall the cumulative effect of that is a huge change in volume. I'm going to let the gas back in, and you'll see it's going to make a little bit of a mess, but it's not going to go back to the shaving cream like it was before because we've sucked a lot of the gas out of it, but you'll mostly just have a liquidy sort of solution. Opening the valve, pressure is increasing. Gas is coming in, and I don't want to make too much of a mess, so I'll do that slowly. All right. That will continue until the pressure has returned to normal. This is Boyle's Law in action. Hope you enjoyed it.